Hello friends, today we are going to discuss about power diodes. So friends, we all discuss about diode, its working principle, its construction and how it operates and how it works. But today we are going to discuss about power diode. And the main difference between a diode and a power diode is its construction and its kind of doping. So as we all know, in case of a diode, there is a p-n junction. A p-type of semiconductor is doped against an n-type of semiconductor. But in case of power diode, again there is a doping principle which is being applied, but here in this case, the p-type of semiconductor is heavily doped and it becomes a p plus, which I will be explaining you later, and a heavily doped n-type of semiconductor which becomes n plus. Now, what is the main use of a power diode? The power diode is used for a very high power application. It is used for a very high current and a very high voltage application. And the amount of reverse recovery time in case of power diode is comparatively less than the diode. So let's see how a power diode is being formed. So friends, let's see how a power diode is being formed. So as I explained you earlier, let's draw the p-n junction diagram of a power diode. So friends, let's draw the p-n junction diagram of a power diode. So friends, as you can all see in this diagram, a heavily doped p-type of semiconductor is doped against a heavily doped n-type of semiconductor, which forms a power diode. So here you can see there is a small n minus region which is very lightly doped, which is formed in between the n plus and p plus junction. Or so here you all can see there is a very lightly doped, so here this is lightly doped. Here you can see there is a very lightly doped n minus layer is formed between the p plus and the n plus layer. So because of this n minus layer, the diode is capable enough in tolerating or withstanding high current and high voltage applications. So here, this portion here or this layer here is called drift layer. So this portion here is called drift layer. Now, because of the n minus layer, which is very lightly doped, the diode is capable enough for withstanding high current and high voltage application. Here you can see this is the anode terminal and this is the cathode terminal. Now let's see what are the types of power diodes available. So friends, here you can see in this figure, the space charge region here is still maintained when a p-type of semiconductor is heavily doped, when an n-type of semiconductor is heavily doped. The space charge region is still maintained. Now, because of the n minus region and a very nice maintained space charge region, so friends, as you can see here, the space charge region is completely maintained or well maintained, or which is sufficiently maintained here because of a heavily doped p-type of semiconductor and a heavily doped n-type of semiconductor. Now, because of the n minus region and well maintained space charge region, the thickness of the space charge region increases, or the space charge region becomes thick enough to withstand high amount of electric current and high amount of electric voltage. Now friends, The entire figure here consists of a power diode. So friends, let's talk about different types of power diodes. Basically, a power diode is classified into three parts. Let's see what are those. Number one is called general purpose diode. Number two is called fast recovery diode. Number three is called Schottky diode. So let's talk about what are all these kind of diodes. So let's first talk about a general purpose diode. So friends, we all know what is a general purpose diode. The general purpose diode is the normal power diode that we use or that are available in the market. So a general purpose diode, point one would be it is capable of withstanding 50 to 5000 volt of electric voltage. Number two would be the current rating would be 1 ampere to several thousand amperes. But the reverse recovery time in case of a general purpose diode is quite high or is quite delayed or the quite wider. So here the reverse recovery time would be 25 microsecond, which is quite high. Now here you can see a general purpose diode can be used for an application which is up to blocking of 50 to 5000 volt. A general purpose diode which can be used to block 50 volt to 5000 volt. It can withstand the current of 1 ampere to several thousand amperes, and the reverse recovery time of the general purpose diode is 25 microsecond. So friend, let's talk about what is reverse recovery time. So let's say TRR be the reverse recovery time. So a reverse recovery time is a time in which once the diode starts conducting and it blocks the supply of electric voltage when it is reversed biased. At that point of time, during the time of conduction, the diode has a tendency, because of its p-n junction, to store some electric charge. Once it stops conducting, it has a very nice tendency, or it has a tendency to discharge the amount of charge it stored earlier. Because of that charge getting discharged, there is a flow of reverse recovery current, and the time for the reverse recovery current to flow, that interval of time is called reverse recovery time. So hope you understood what is a reverse recovery time. So we understood, friend, more the reverse recovery time, late will be the application of a diode, and when the reverse recovery time is slow, the diode application will be faster, or the diode operation would be faster. So friends, this is all about the general purpose diode. Now let's talk about fast recovery diode, but before that, let's talk about applications of a general purpose diode. So basically, the general purpose diode can be used in an UPS, in SMPS, in many converter circuits, in many circuits which operates in a low frequency mode, and in many power converters as well as motor control application. So friends, let's talk about what is a reverse recovery time, because I introduced a reverse recovery time which is around 25 microsecond in case of a general purpose diode. So let's discuss about reverse recovery time. So let's say TRR be the reverse recovery time. So a reverse recovery time is a time which is the amount of time for which a reverse recovery current flows. So friends, what is a reverse recovery current? So let's discuss about it. When a diode is on, that means it is connected in an electrical circuit in a forward biased mode, there is a flow of electric current. But because of the PN junction, it has a very nice tendency. So friends, when a diode is connected in a forward biased mode, the current start flowing through the diode. During the flow of electric current, because of the PN junction, the junction start storing some amount of charges in it. And when the diode is reversed biased, that means it stops conducting electricity, the reverse current or the amount of charge which is stored in the PN junctions start discharging. Because of this discharge, there is a flow of reverse current, and the amount of time for which the reverse current flows is called reverse recovery time. So friends, you all can see, if the reverse recovery time TRR is more, that means reverse recovery current is more or the diode is slow. If the reverse recovery time is low or small, the diode is fast. So friends, for a general purpose diode, the reverse recovery time is 25 microsecond, as we discussed. Now friends, let's talk about some application of a general purpose diode. Number one application of a general purpose diode would be UPS, which is uninterrupted power supply. General purpose diodes are widely used in UPS. Number two would be battery. The general purpose diodes are widely used in battery chargers. So the general purpose diodes are widely used in the welding application and the traction application, etc. So now friends, let's talk about what is a fast recovery diode. So friends, a fast recovery diode is a diode which has a reverse recovery time of equal to or less than 5 microsecond. A fast recovery diode has a recovery time of 5 microseconds. So we can compare between the general purpose diode and the reverse recovery diode. The fast recovery diode are faster than the general purpose diode, because in case of a fast recovery diode, the reverse recovery time is very smaller as compared to the general purpose diode. So let's talk about some other criteria of a fast recovery diode. So let's say this is number one. Number two would be it can withstand a voltage level up to from 50 volt to 3000 volt, which is very less compared to the general purpose diode, because general purpose diode can withstand a voltage of a range which is equal to 50 volt to 5000 volt. Now in this case it can only withstand from 50 volt to 3000 volt. Now number three would be the current rating, which is almost the same, which starts from 1 ampere to several thousand amps. Continuation this topic. So now let's talk about the applications of a fast recovery diode. So friends, fast recovery diodes are applied or are used in various applications. For example, number one would be SMPS. They are widely used in SMPS. They are widely used in commutation electrical circuits, and they are widely used in choppers and etc. So friends, if you can see, the less is the reverse recovery time, the diode can be used in a very high frequency application. That means the frequency range of a fast recovery diode can be higher than the frequency range of a general purpose diode. Now friends, let's talk about the type 3 diode, which is called the Schottky diode. So friends, the current rating of a Schottky diode is less compared to the general purpose diode and the fast recovery diode, and the voltage rating of a Schottky diode is also less compared to a general recovery diode and a fast recovery diode. Now let's talk about the voltage rating of a Schottky diode. The blocking voltage rating of a Schottky diode would be up to 100 volt. The current rating would be 1 to 300 ampere. Now we can compare this diode with the other two kind of diode. Here the current rating is comparatively less than the other two types of diode. The reverse recovery time for this kind of diode would be it has got the least reverse recovery time. That's the reason this is called the fastest diode, and the reverse recovery time of this kind of Schottky diode is in the figure of several nanoseconds. So friends, you can guess how fast is this diode. Now let's talk about the various applications of Schottky diode. Because of the fast recovery time or because of the very small reverse recovery time, this kind of diodes are used in a very high frequency application. For example, very high frequency converters, very high frequency inverters, very high frequency motor drives, and very high frequency electrical applications. So let's talk about the applications. So this kind of diodes are used because of its excellent performance in a very high frequency application. They're used in very high frequency operation, power supplies, and power converters, etc. So friends, thank you so much for watching this video. Please subscribe to Ekeeda and stay tuned with Ekeeda. Thank you so much.